All right, here we go. We are graphing sinusoids, our graphs of cosine or graphs of sine, and we're going to be dealing with transformations of them. So here's the big concept for this one. We're going to be taking those graphs and moving them around. Got an example of it here for you that if we have the graph of y equals sine of x or f of x equals sine x, here that is in the blue. Now what we're going to be doing is moving it. So notice that graph from the original, here the original line was at, that black line, and the blue one is simply just one higher. Well, how would we write that in our equation? It's just plus one. We've done translations like this before, and so hopefully this makes sense. If I move it up another one, now it's going to be plus two, plus three, so on and so forth. Go back down to where it originated from. Now what if we subtract? Okay, these are all the y values. The function of sine x, that's completed, and then after that we're subtracting 2 before we get our final output value. Now same idea when we move left to right, when we move horizontally. So we just did vertically, and now we're going to do horizontally. Notice that when we went 1 to the right, that's the x value being affected, and it's minus 1. That 1 is the x value that we've moved to the right. And it helps to think of what would have to happen over here to make kind of this thing in the parentheses equal to 0. That can remind you, but the horizontal is inside that parentheses. We'll talk about the general equation in just a moment. It's going to be always x minus that value. But I think at this point you guys are getting pretty used to that. And so here it is. We can also go to the left. So now that point that was at 0, 0 is now at negative 2, 0. And so it's minus a negative 2, meaning x plus 2. And obviously you can combine these as well. 3 to the right and up 2. Think about what that equation would be if we went 3 to the right and then up 2. So we're going to affect our y value. It's going to be a plus 2, so probably going to be a plus 2 out of the end of this. And it's 3 to the right, so that's going to be x minus 3. Let's see if that's correct. There we go. We've got sine of x minus 3, the quantity x minus 3, and then finally plus 2. And so there's that same point that was at 0, 0, now is all the way over here at 3, 2. Okay, so let's wrap up this video here. If we have the graphs of y equals a times the sine of bx and y equals a times the cosine of bx, that they're translated horizontally h units and vertically k units. And we've talked in class, I often prefer to use v just to remind myself that it's vertical. And then the resulting graphs have the equation. So we'll have y minus v or y minus k equals a times the sine of bx, or sorry, b times x minus h. Same thing with cosine. And there we've got it. That's if you think of it in terms of kind of comparing it in your mind to when we did things in vertex form, imagine if we had added v to both sides of the equation, that we would have something like y equals a times sine of b times x minus h. And then all at the end of it, if we had added v to both sides, so now we just have y equals at the end of it plus v or plus k, whatever that vertical translation is going to be. All right, hope that helped.